Okay, let's start. This is the lecture 12 for incident response technology class. So I will finish the dynamic analysis slide, then give another lecture slide, the last lecture slide on dynamic analysis, which is a case study on analyzing actual binary running program. Okay. See. Okay, I will tell you when will the midterm exam will be next on next class. Then basically next time I will determine which class time we will use for the midterm exam. It will just be 1 day homework. You can think that it's like 1 day homework. And in that time, there will be one lecture time that I will not give the regular lecture, just with 1 day covering that either Monday or Wednesday. So on that Monday or Wednesday, there will be no lecture time. Okay, let me finish this first. So last time we mentioned strace. Let me open my Kali Linux. And strace is a very useful program. Basically, it displays all the system calls that have been made by the running program. And you use strace, then put the running program here, let it run, then strace will tell you what kind of system calls and also the parameters for those system calls used by the program. You can use this -auth and a text file to record all the text output because the text output will go very long, especially for some large program. So you can use strace to minimize the output. For example, only display this system call like open. All the open system call will be displayed. This one is only displays the strace for a given process ID. If you have some running program that already run in the background, then you can use strace -p, give that PID, then record down what system call has been used by that already running program. Because for this way, you need to start running the program under the strace monitoring. This one is you can monitor some background running process. As I mentioned last time, strace is not installed by default, but strace is in the Kali Linux App Store. So you can use this simple apt-get install strace to install this program. For example, we run, I have already installed this one last time. So let me just put to the same file. Suppose we strace dig command. Yeah, I think I haven't mentioned dig command before. In the shell, you can use file and add a new tab. So then this will be this is all the shell, and this is a new shell. They will be put just like a browser tab by tab, so that's easier for you to manage. And by default, it's transparent, so you can see the background. If you want, you can like edit preference to make that transparent go away. Like this transparent is 5. So let me remove that transparent. Then you cannot see the background. Sometimes transparent is annoying. What's a dig command? Dig command is a DNS query, basically send out DNS query. So if you dig like a google.com, then basically dig program will send out DNS query to query the local DNS server, what's the IP address for google.com? So this is type A record for DNS query, the answer, which tell you the IP address is this. And so that's a basic function for dig command. So suppose we use this strace and save the output in the output.txt and dig, for example, MX record. MX here just means we try to find the MX record for UCF audio domain. MX means is the email exchange, mail exchange. So so it's MX. Basically, you can use dig. The most common the DNS query is find what's the IP address for domain name. But for email system also use the DNS system. So here is basically ask what's the email server that corresponding to this email domain. This email domain just whatever after this at, because your username at, then that is the email domain. So suppose let me use your NICE account because you are more familiar with that. So nice.ucf.edu, that is your email address, and this basically ask what's the email server's domain name or IP address corresponding to this email domain. So that's the dig command. If you use the dig command directly to that, directly find what's the email server for that, you can get this answer. This is answer section. Answer mixed record is this one. So this is actual email server in charge of UCF student email system. We remember every student has this NICE account. This NICE account, the actual email server is this one. So you can basically see that our student email system has been outsourced to Microsoft. So student email do not use any email server locally anymore because we have so large student population. So we have outsourced. And here, the additional section basically tell you, well, the IP address. IP address is called type A DNS record. So the IP address for this email server is, there are two IP addresses corresponding to that email server. So this is a dig command. If you use a dig UCF faculty or staff, we have this, like me is a changchun.zou@ucf.edu. So that is a faculty staff email server. And you can see that faculty and staff email server still using this email server locally. So the IT department manage faculty and staff email by themselves. They set up email server locally, but for student account, they outsource to Microsoft. So that's the dig command. And let's do this strace. And you can see the strace output will be saved in this output.txt file, but the dig command, dig program, its output will be output to the display. So now we can see, let's use editor like a pickle output.txt. And you can see that this is this strace. The dig command will actually call execve. This actual dig is in this USR bin directory. This is a command line option, and you can go down to see this is the readf, this is map, this is close, open file, and so there are many open at, for example, and read an fstat. Fstat is check the file status. So it's hard to read manually because even for this small dig command, it has such long things. But you can analyze it using any text editor to find. Suppose I want to find how many fstat system call is in this strace output. I can use this grab command, grab like fstat in this output.txt file. So this grab is if you're familiar with Linux, then you know that grab is a very powerful text search program. So grab basically search any text line that contains this keyword. Then you can see that, well, in this program, the fstat has been called many times. If you find execve this system call, well, this system call only called once at beginning grab, and so you can use this way to find any system call that exists in this strace output. For example, if I want to find how many this get PID is, I can simply grab get PID. You can see this get PID has been called 6 times by this dig program. So that's how you use strace, and also how you can initially analyze strace output. You can use grab. If you want to do more detailed analysis, you can use some other text search or text editing program to do that. Okay, so that's for the Linux. For Windows, Microsoft have provided a suite, basically a bunch of free small Windows program, and it's called CIS internal. And you can download it from this page. And this is Windows CIS internal. And you can download, for example, you can download either a category of software tools. Like if you want to download process utility, you can go here. Or you can download the entire CIS internal suite. It's not that big. It's just less than 50 megabytes. So that's what I did. And I think I have put it in this map in the web course that dynamic tools that zip file. So it contained in that zip file. And CIS internal, this one is safe because it's from Microsoft. It's from official website, so you can use it on your own host Windows. Or you can just download in your Windows VM and try it out. Here are some tools that I will briefly mention. This Process Explorer, this is similar to the PS program in Linux. PS program in Linux will show all the running process and the information. Process Explorer does exactly the same thing. Process Monitor will show file system, registry, and the process activity. So that not only show process information, but also show what file has been opened right now by any running process on the computer. This one is show DLL. This is show this ongoing TCP connections or UDP connections. So I will explain briefly. This once you download. Let me see. I think I have put in my Windows static dynamic. Okay. Oh, it's I downloaded 7-zip, which is a free compression software. So CIS internal is here. So CIS internal basically contain a lot of running programs. They are all very small, and they are all in one directory. So let's first show this process explorer. It's a proc XP, so that is this program. This is proc XP for 32-bit. This is for 64-bit. I think my Windows is 64 bits. Let me run this one first. Okay, so this is a process explorer. It will show like all the running background process. Of course, in Windows you can use Control-Alt-Del, then show process. But that showing process will show only simple information of all the running process. This process explorer will show much more detailed information of the running process. You can see this process is run. This is Chrome, like you can see that Chrome, it has multiple running threads. So Chrome is a multi-thread program. So it runs in your program, in your computer, in multiple threads. It will show the company name, and if you move your mouse to any process, then this pop-up menu will show where this file is located and what's the command line for that process. And you can right-click and you can kill that process or suspend that process. You can check various total. You can then, it will automatically upload this running process content to various total and check whether it's have malicious code or not. So this is a property. So you can see this property has much more information. It showed all the thread. So right now Chrome is running in multiple threads. So this is how many threads is running currently in your memory. So this is this process explorer. And you can also see the registration key. Let me see. I think right now this default view does not have the registration fee because in my screenshot here, when I click anything, it will show what kind of registry key it has been used. Showed on the second window. But this one, I don't know where to show that the registry key.
Dr. Zun, maybe click the icon and up and above, 1, 2, 3, 4, fifth one from the left, right between view and process, that icon. In the top of your toolbar. No, go up to your toolbar where it says view.
Toolbar. View.
Right under process, come down, you see that icon? No, not in the menu, sir, it's the icon. Yes, toward your right. Yes, that one there.
Oh, okay. Thank you. I don't know. Yeah. It's that's the show lower icon. Okay, yeah. Thank you for pointing out. So this is a lower panel that it will show some information. Like this key is registration key, the event, and section. Let me show another one, Chrome. So this is a thread and the section, process, and the key. So there are a lot more information that I don't know, and I don't know yet because I haven't done this using this program that much. But this one showed much more information than when you use Control-Alt-Delete and show the process in Windows. Okay. Another one that is useful is process monitor, ProcMon. Let me show you that. ProcMon. So it showed PID and the process name, and well, it showed a lot of information here. I see. Chrome. Let's see. It's hard to go over because there are so many. Yeah, probably you have to use search function. Let me see. Chrome. I couldn't find Google Chrome. Oh, okay. So you can see this. This is a Google Chrome link, but it still showed the Explorer.exe basically is a file explorer in the Windows, but there are a lot more information. It's hard to use if you don't know where to search, and but it provides very detailed information that you can have. Maybe the best thing is that you can save the result and use some text search program to search for the thing that you want. So I would just give brief introduction here, but I will not. I haven't used this program by myself that much. So just to tell you that these are the normal Windows program that you can use. The TCP view is just to show the running program. If you want to see what explanation, you can just go to this link. It will tell you what is the program is doing and how do you use it. So this is a brief introduction of the TCP view. So TCP view.exe. TCP view. Again, those need a root privilege. So when you run TCP view, you need to have the administrative privilege. It shows all the opening connections. Right now, it's a loop back. Like this one is loop back, and this one is the system. 2.15, I think 2.15 is my IP address. Yes, 2.15 is my IP address. Suppose I connect to another website. And check this again. Refresh. Chrome, let me see. This is called time wait. So this must be that web server I just connected to. But I don't know why it put in this process information, not in the Chrome program part. For TCP. Let me see, N has look up like a CIS6395. I find what's the IP address for this one. Is 10.171.12. Yeah, I don't know how it display. I couldn't see this ongoing TCP connection myself with the CS web server. For any student know the reason, because I haven't used this that much. TCP view. The remote address. What is this remote address? 10.200. One issue is that I think is possible the reason. Let me connect to a outside web server, because if I connect to a UCF web server, because I'm in the UCF campus network, UCF web server, it has the private IP address, but private IP address, it cannot be show up. Suppose my computer is in this local virtual line. Local virtual line, when it connect out, it should not connect to a private IP address. So there should be some problem. Let me connect to google.com. Then refresh. Chrome, UDP, TCP. This one, 142. This is basically Google's computer. So this one. So I think time wait, this one is from my computer, which is Google's computer on 443 connection. Because if you right click, you can use this whois, and whois can tell you that this domain name is from where. This is Google last update. Let me see. Register is Mac monitor. I don't know why. So sorry about that. You can either search that address, use whois online search to find this IP address. Let me use. Because this is dynamically changed, so this is 142, 250, 142, 250, 142, 250, 68, 67, 68, 67. Let me see. This capture is annoying. Click the new image. What is this? Okay, yeah. So that is Google. You can see. So that connection. This connection is to the Google, but it put in this time wait category, not in this Chrome category. So this one is showed ongoing TCP connection. Is time wait is ongoing. I don't know why it doesn't put in this Google Chrome category here. Let me see. Okay. To understand how to use it, we have to find more tutorial on how to use this cross monitor to find detailed information. This is a TCP view. It's also like that, established state. TCP views, older version has this state listening established, which is like in Linux, that's not stat. Where is the newer version? Let me see.
State is further to the left, sir. Next to protocol. You want to choose what column?
Protocol state. Okay, state is listening established. Okay, so this is established, and the other is listening as the host. Let me reconnect to another website, for example, CIS6395.com. So this should have established some TCP connection. Let me this is established. Oh, okay, so these are established because I just connect to CNN and because this website has many objects, many pictures, things, so it established many TCP connections. So those are included in this established state. Okay, let me move on. NetStat is included in Windows, so it's already included, so you can run it in the command line. NetStat will show network stat. So it's similar to the Linux. In Linux, you also have that NetStat. Let me close this one. If you directly run NetStat, it will show the TCP connections time wait. So it's similar to that TCP view, but has less information and showed only in the command line format. Here you can use save the output and add some command options and save it to a text file, then you can analyze. So you can think that NetStat is a command line version of the TCP view, but has less information than a TCP view. Okay, the last in this dynamic analysis I want to introduce is a small program. It's called RedShot. A RedShot is basically because if you install or running any program, they may create some new registry. They may modify some registry in this Windows registry file, because Windows save all these, many programs, they will save some configuration settings in this Windows registry. So RedShot will take a snapshot of all the registry information. And then it can take a snapshot twice and compare these two snapshots to see what's the difference between these two snapshots. So if before you run any suspicious program, you can use RedShot to take a snapshot. Then you run this suspicious program in the virtual machine. After you finish running it, you take another RedShot, take the second shot. Then RedShot can give you a report to see what's the difference between these two registry information, to see what kind of registry has been created or modified by the running program. Because most malware programs, they will create some registry file. They could also modify or delete some system registry information. So that so this is useful in that sense. And you can also use RedShot to monitor for file change. Basically, the RedShot, not only you can take, by default, it can take system registry snapshot. You can also take MD5 hash value for a specific folder or directory. So here, you can go to this file option and check files in the specified folder. For example, if you suspect that a malicious running program could modify your system file, because many malware, they will modify system file. So then you can use this RedShot to specify the files in the system folder. And then it will calculate MD5 for every file under that folder and save it. The next time when you take the second snapshot, it will calculate MD5 again, then compare these two sets of MD5, the hash value. If any file has been modified, the hash value will be different. So that's another way to monitor. So in this way, it's very, very similar to tripwire. Tripwire is a special antivirus software which take the MD5 hash value for every system file on your computer, keep monitoring. If any system files has been modified, then Tripwire will give you warning to tell you that this system file has been just modified. So Redshot will do something similar to that, and it generate report. So let me see. I have Redshot here. Let me see. I don't know what's the difference between ANSI or this Unicode. I will just so compare log saved as you can take first a snapshot. This is output file, and here, if you want to take MD5 hash value for some folder, you can enable this. Then select which folder you want to monitor the hash value. But this one, if you have too many files under that folder, then Redshot will take a long time to take because it needs to calculate the MD5 hash value for every file under that folder. So that will take a long time. Let me just take the registry shot. So you first take one shot, and then you can see this the keys, because in the Windows registry, every value is assigned to called as a key. So you can see there are many keys in this Windows registry. I don't know how long it would take. Okay, so right now it has finished. I don't want to run any malicious program. Let's see if I can run any installation program. If you install any program, like WinZip, suppose I download a WinZip and install it. And then I take the second shot. Then you can, after the second shot finish, you can click this compare button. Then it will generate a report to show what's the difference between first shot and second shot. Because like I just run the WinZip installer, so it must create some new keys in the registry that will show up in the compare report. Okay, the last part is just a brief explain of assembly language. Assembly language itself could be a one semester class, so I will not introduce that much. Just to give you some basic idea, at least you understand the most common assembly language command is, what is that command? Because that is needed to use in the case study. I only introduce 32-bit assembly language because that is the most commonly used. In current computer architecture in the CPU, CPU has many register, because register is basically a memory part that is fast processing in data. And 32-bit machine, every register is 32-bit. So this is 32-bit. And register, there are some common general purpose register for all the operation, for all the mathematical operation or other logical operation. You can use the general register to save anything. There are also some special register that has special meaning. Those special register, probably you cannot directly use them in your own code. They are used by the operating system for that purpose. And also a flag register. This flag register is used for conditional jump, for logical operation. In 32-bit, this Intel-based architecture, the common register, this general purpose register is ABCD plus these two, the ESI, ABCD originally it's called ABCD register. Because Intel CPU is backward compatible, so it is directly, it is start from 8-bit. In early stage, Intel CPU is 8-bit CPU. So at that time, the register called AL, BL, CL, DL. So in the 32-bit machine, you can still support computing or comparison, all those instructions. So you can use AL to represent only the first 8-bit in this register, and AH, the higher 8-bit of the register. You can use AX to represent the up 16-bit of the register. The whole register, you use EAX to represent this whole 32-bit. So in this way, your code could be backward compatible. You can still run very old programming code in 32-bit machine. So this is why there are so many names. So in current program language, you can still use AX, AH, AL in your assembly language to refer to different parts of this common register. ESP is used, it's called stack pointer. EBP is also for base pointer. So ESP is used by the stack. So normally you should not do anything for this register. This register is used by the operating system to do stack operation. EBP is used by the operating system to do function call operation. Function call, the EBP will save that function calls, where this function call start, where it ends. So those information. Let me see. I think this one should already finish. So after you take the second snapshot, you can do the compare. It will generate the report. The report in HTML format. So I will just use Google Chrome to open the report. So this is the report. It showed that it has deleted 10 keys and added 963 keys. So not all of those keys is because of the WinZip. Like this is the WinZip. I just installed WinZip. So those new keys are added because of WinZip. But some old keys, they are removed, they are deleted, like some cache. Those are temporary key. So those key deletion is common. But if you find any key deleted here, belong to like some system program, then that is suspicious that why this program deletes some system key. So this is a newly added key. Even for WinZip will add a lot of new keys in here. And besides this key, it also value deleted and value added. Because for each key in Windows registry, each key, you can have multiple value for that specific key. So there are more keys to be here. Again, this is not easy to analyze. You need to know where you are looking for, what information you are looking for in order to analyze this report. But anyway, this report basically does what it's supposed to do, is check the Windows registry key and take 2 snapshots, compare to see what has been changed before the 2 snapshots. So that is the right shot is used for. Okay, let's come back to this. This is to define a variable. Define a variable, how many bytes you want to use for that variable. Like TB means declare bytes. TW means declare word. So this is 16, 2 bytes. Declare double, basically 4 bytes will be used for that variable. So this is var2. These 2 variables, they are all byte value variable. And you can use this dupe to declare an array, like duplicate how many times for that. Like this db10 dupe. This means you declare 10 bytes value for this bytes variable. So basically, this is a byte array, and initial value is uninitialized. This one initial value is 0. Declared 100 unit. Each unit is DD, means each unit is 4 bytes. So declare 104 byte memory to allocate to this variable, and initial value is all 0. So this is a declared a byte string, but with some initial value. This 6 bytes, and with this 0 value byte at the end. So that's you declare a string array. And basic operation is a move. So that's the most common assembly language command. Move, you move the second register to the first register. If you have this square bracket means address. So if you directly move EBX to EAX, then basically move the EBX content, the register content to this EAX. But here, because we put a bracket, then it means that this is a pointer. The value in this EBX register is a pointer. So that means we move this memory address location content, 4 bytes content to this EAX register. So this square bracket just means address. This second move is move this EBX content to this address place, because this square bracket means address, so refer to address place. And this is a move byte pointer. So PTR means pointer. Byte pointer indicates size of 1, 2, or 4 bytes respectively. So move the value 2 into the single byte at the address saved in this. Again, this is a square bracket. So this is the location, and you move this 2 value into only 1 byte at this location. Here is you move this value 2 into 2 bytes. This word PTR means 2 byte value at that corresponding location. This is 4 byte memory at that memory location. You use this value 2 to assign to that. So that this specify the size at that specific address location, how many bytes you will be used to fill in that value. So this byte PTR, word PTR, dword PTR is to specify the size. So normally move is source and destination. So it's used a little bit awkward. Source is the second, move to the first destination. And LEA is a little bit difficult to explain, so I will not explain that one. Push pop is used for stack. So you can, every time you use it, always 32-bit because this is 32-bit machine. So every time you push and pop, it's always 4-byte value. This EAX registers content into stack. This push is a push of 4 bytes value at this location. This var is a pointer. At this location, 4-byte value into the stack. This pop the 4-byte value and save it in this EDI register. This pop, because this is a square bracket, so the popped 4-byte value will be saved at this location. This EBX has this address value in this EBX register. That's a push pop. And arithmetic instruction is add and sub. So you add 10 value to this register and also save in this register. Basically add the second value into the first register and also saved in the first register. So add 10 value into this single byte value in this location, in this address. Of course, you can use this older register name AL, AH to so here you represent that 8-bit value in that register. Increase. This one again. This specify that we operate on the 4-byte value at this location. This increase, decrease one value from this register. Multiply, division. It only have integer multiply, integer division command. So this is multiply division. So if multiply the first operand must be a register, not memory. So integer multiply the first operand must be a register because the saved output should also be in this register. This is the second operand multiply with the third constant value will be saved in the first register. This one is multiply the content of the EAX itself with this. If you only have 2 operand, then basically these 2 registers into content multiply together. So that's the multiply. And the logical instruction mainly is XOR and OR. So those are the logical instruction. And not is flip. Every bit will be flipped. Shift left, shift right. So from the name, you can know that it's shift every bit in that register. One position left or one position right. You can shift by multiple positions. So shift left by 1, it just means multiply that value by 2, because that's the meaning by the shift. And stack is used managed by operating system. It's used for system call. As all the subfunctions content, temporary value, local variable is saved in the stack, and it has two command, push and pop instruction. Every time it's always operate on 4 bytes value. So that's the push and pop. Stack is the last in, first out structure. So you need to understand at least that part. And jump and conditional jump is an essential part for computer. Computer need to do logical operation. So they all depend on this conditional jump. This is unconditional jump. You jump to a specific position. Normally, jump is a conditional jump. Before any conditional jump instruction, you always have some comparison instruction before it. Usually is compare. And this is compare to register value, usually is that. Then this compare result will be saved in this flag register. So remember in this CPU has many registers. There is one special register, it's called the flag register. So this flag register will be changed after this compare instruction. Then after compare instruction, you have this conditional jump. Conditional jump will use this value in this flag register to determine which path to jump. So like compare, if you compare EAX content with EBX, if EAX value is less or equal to EBX value, then it will jump to this instruction. If EAX value is less or equal to EBX, then jump to that instruction. Basically, this compare would change some flag, change whether it's 0 or 1. Then this jump less equal or jump not equal. These will use that bit in this flag register to make the decision. So here is jump equal, jump not equal, jump 0. If the last result was 0, then you would jump to that label. Jump greater or equal. So those are the things. And for a subroutine call, subfunction call is just a call label. Basically, label point to the first instruction in that subfunction. Then when you return from that subfunction, you use this ret, basically return. So this call and return, these two instructions will be processed by the operating system to operate on the stack to do this stack operation. Okay, some general principle for using debugger in malware dynamic analysis, which I will show in the case study next. In the case study, I will use the debugger to actually run this binary program under the debugger in order for you to analyze it. But if you want to use debugger to analyze a suspicious potential malicious program, you should set up a virtual environment. For example, the best way is to set up a virtual machine and also make sure your virtual machine does not have internet access, and make sure the virtual machine is in its own virtual line. Basically, it cannot connect to the host OS. It cannot connect to any other virtual machine. So that is a sandbox environment. Make sure it is isolated. Then you can run debugger to run this possible malware. And do not share folder files between the guest OS and host OS. Because sometimes for convenience, you may share a host OS folder to the guest OS, to the virtual machine, because you want to move some files. But before you do this operation, you need to cut off any sharing between them. Do not allow internet access. Running the malware from a debugger may infect the sandbox guest system, especially some potential virus or worm. Then you must take precaution to contain the risk of spreading the malware. So after you running, the best way is that after you get the information you want, you delete the virtual machine. You can re-import a virtual machine. So this is a basic procedure for malware analysis. First is static analysis. Do not run the code, just use some software to analyze its source code. Dynamic analysis, if you run this in a sandbox environment, you can either run it under debugger, or you run it, then you use this like a Wireshark to check its network activity, TCP view to see what kind of network connection it's trying to open, and some other tools to find, like strace to find out what system calls has been used by this program. Then you load the malware in the debugger. You can set breakpoint on memory access or some instruction, and you start. You monitor the change to the guest OS. If you use debugger, you monitor this in much more detail. If you don't run debugger, then you can use like a red shot to see what registry has been changed by that potential program, and you iterate here. So this case study is this case study could be interesting because anyway, when I teach, I always want to teach things that has concrete example. So the case study actually is from a puzzle. It's like a cybersecurity challenge. It gives you a puzzle. This puzzle, I basically copied, summarized from this blog. These persons gave a blog. It tried to solve that puzzle. This puzzle is from the hack.lu. They gave a puzzle, basically give you a binary program, and this puzzle asks you to input 2 passwords. And if you input the 2 passwords correctly, you finish the puzzle. If you only input the first password correct, but not second password, you get partial point. If you don't know how to analyze this binary program, you cannot find out both passwords for this program. So that is a challenge. Basically, ask you to do some binary analysis for this binary program. The program itself is not malicious. It's just a normal program. Need you to find out the 2 passwords included in itself. And this book has 1 chapter introduced this puzzle as well, and it has some slides. I used some slides from this book. This is a good book, hands-on book, that it has all the detail that you can operate by yourself, following the instruction on the textbook. The debugger we are going to use is basically only debug. This is a free open software. It's a free software. It's not open source software, so you don't know the source code, but it's a free software. For commercial company, they usually use this IDA Pro as a debugger to analyze, to reverse engineering. This is mainly used for reverse engineering any software. But IDA Pro is not a free software. It's very expensive. But of course, it is much more powerful than only debug. Actually, the PE Browse Professional can also show the assembly language. We have shown that before. When you click that .text section in the binary program, you can actually see the assembly language for that program. But it can only show that. It doesn't have further analysis for you to do. Like a disassembler, the first function you need to have is set a breakpoint, and you can run the program and make it stop at that breakpoint. Okay, let me before I finish this class, let me explain this puzzle first. This is I will only introduce using this debugger to solve the first half of the puzzle, because the puzzle needs you to find out 2 passwords. The second password needs more advanced reverse engineering techniques to find out what's the second password. The first password is relatively easy. for you to use a debugger to find out the password. So, and it was explained by that person in that log, in that blog. So I will just show that one. This program is annual program. You can run it under Windows. You need to basically you can. I have downloaded to my Windows VM. When you run it, it first print out some text. It shows this. This picture is just drawn by print out ASCII character. So it's very simple text. Then you input the first password. If the first password is wrong, it will stop. If the first password is correct, it will tell you that you find the first password correctly. Now input the second password. So that's the very simple program. But this program is a binary program, so you cannot see clearly what's the actual password used for this first challenge. You have to use a debugger to find it out. And to debugger, you can use Oli debugger, which is popular. Another is called Win debugger. It's also free. It supports kernel mode debugging. For our case study, this robot authenticate program is run under the user's privilege, so we don't need a kernel mode debugging tool to do that. So it's because this is free, so it is popular for malware, for reverse engineering by many users. This is a puzzle cybersecurity challenge in 2013. I don't know if you can find the other. Let me see if I can find. Crypto. So in 2013, its challenge has several categories. Reverse engineering is that robot authenticate one. Crypto asks you to solve some cryptography problem. Reverse engineering, robot authenticate is one of those reverse engineering challenges. There are several other challenges. Well. This one seems to have a lot of other. Seesaw. Seesaw is another cybersecurity challenge. And it has so many information. So I think this is a good website. If you are interested in those cybersecurity challenge, the older, in the previous years, some cybersecurity challenge, like DEF-CON is also well-known cybersecurity challenge. And well, this website is just a repository. It doesn't give you explanation of the information in them, but it has all the actual things here. So you can check all these old ones. That is interesting. Okay, I will finish this one. It only have 10 pages left, so I can finish within half an hour in next class time. I think that's all for today's class. And I will tell you exact midterm exam time in this Wednesday's class. Okay, that's all for today's class. Thank you.
See you Wednesday.
Thank you, Professor.
Bye. You want to ask, do we post the solution? If you want solution, you can email me. I can send you. But I try not to put the solution because once I put the solution, it will out. And next year I have to change the assignments. Yeah. Thank you.
Professor,
Yes.
can you tell me when the office hours are?
Office
These
hour
days,
is
'cause
office hour. If you check the syllabus, it has office hour information.
But then we got a email that said it was changed to a different time on Monday and Friday.
No. Oh, that. I didn't send email. Maybe that is a TA's email. TA also has office hour, but my office hour is showed here.
It's as it is in the syllabus.
It is in syllabus, Monday, Wednesday, 12 to 1:30, because I need some time to walk back to my office.
Right.
And the Zoom link is in this.
Yeah. Okay.
It's
Yeah. Great. I was confused. I'll get back on them. Thanks so much.
Okay.
Bye.
Okay. Bye.